Hello. Today, what we're going to be talking about is section 7.6, both radical and exponential equations. So today we're going to go over three exact copies or types of equations. First of all, equations that contain radical, but the x is not in the radical. In other words, just like the square root of x, it's not there, but maybe it's like x times the square root of 3 equals 4 or something like that. The second type is the equations where x is in the radical. And the third type is where x is actually an exponent. So it's 2 to the x power equals, say, 4. I'm figuring out what x equals. So that's what we're going to be learning today, three types of equations. So let's get started. Here's the first example. We have 2x minus the cube root of 16 equals 10 times the cube root of 2. So if you think about this, here's my x, and that's what I need to isolate. Okay? Also, to make things easier, look, this is the square root of 2, so somehow we have to get that equal to the square root of 2 as well. And how are we going to do that? So let's see how they did it. Let me enlarge this a little bit for you. So they reduced the square root of 16, the cube root of 16 first. So they've reduced that to the cube root of 8 times 2 because the cube root of 8 is 2. So therefore, the cube root of 16 really is 2 times the cube root of 2. So since that's subtraction, we're going to add 2 times the cube root of 2 to both sides. To get rid of that, and therefore we get 12 times the cube root of 2. So then all we have to do is divide both sides by 2, and x equals 6 times the cube root of 2. So let's try another example. And this one, x is here all by itself. We have a square root of 2, a square root of 2. So that seems pretty easy. So that means it's x minus 5 times the square root of 2 equals 3 times the square root of 2 plus x times the square root of 2. But, ooh, I've got an x over here. I have to isolate that as well. So if we move all of the x's to the left side and everything else to the right side, that's what we're going to do. So you add plus 5 times the square root of 2 to both sides, and you subtract this from both sides. So simplifying, you get x minus, add one more step in here, x minus x times the square root of 2 equals 8 times the square root of 2. So then what they're doing is to say, well, since we're solving for x, we want to solve for x. So let's factor out the x. So that would be x times 1 minus the square root of 2, because this is the same as 1x. So we take the x out. Then all we have to do is divide by 1 minus the square root of 2 on both sides, which is what we just learned how to do, making sure that we multiply by the conjugate over here. And simplifying, we get 8 times the square root of 2 plus 16 over negative 1. Get the negative 1 out of the denominator, and you're left with this. So a little bit more involved, but not too bad. It's all things that we have been doing in the last couple of sections. Okay, so notice here on the bottom, it says a different approach is required if the variable is in the radicand. So that means, guess what? That was the first type of equation, and now we're going to do the second type of equation. A radical equation is an equation that contains a variable in a radicand or has a variable with a rational exponent. So this is my second type, and then this will be my third type. So before we get that, notice that in order to solve it, you're going to isolate the radical containing the variable on one side and then eliminate the radical by raising both sides of the equation to the appropriate power. What does that mean? The square root of x equals 4. So how am I going to get rid of the square root of x? Well, we've already done that. We've already said that's the square root, so therefore we're going to square both sides. So this is kind of just reminding us of that. So the square root of both sides, so therefore x equals 16. But what about if it's a cube root? Now what do we do? Cube root. Well, that's not too difficult. We had cube roots in the denominator, and we had to make sure that there were 3 of them, so it's kind of the same way. So if it is a cube root, then we are going to, like here, we're going to cube both sides. If it's a 4th root, we'll both raise both sides to the 4th power. Okay, so isolate the radical and then get rid of it by squaring it, cubing it, taking to the 4th power. This n here just is showing you that, hey, if it's n, you take it to the nth power, and that could be 1,000,000. All right, so let's try and solve one of those. So here we go. We have 3 times x. Look where x is in the radical, right? Minus 2 equals 10. I need to isolate. So the first thing I'm going to do is get rid of that negative 2. So I add 2 to both sides, and then I get 12. But now, sorry, I don't like that one. The second thing I got to do is get rid of the 3. So we're going to divide by 3. So x plus 4, the square root of x plus 4 equals 4. So what do we do to get rid of a square root? We square it. So we're going to square both sides. So x plus 4 equals 16. Subtract 4 from both sides, and x equals 12. With this one, though, you do have to check because you might have an extraneous solution. Look down here in this box. It says squaring both sides of an equation may introduce extraneous solutions. Consider that the square root of x equals negative 4. Squaring both sides produces x equals 16, right? If I do this and this, I get 16. But the square root of 16 doesn't equal negative 4. Any result that does not make the original equation true is not a solution. So if none of the solutions check, then there is no solution. Remember, even indexes cannot have a negative radicand. So we put this back in, we do the check. All you do is go into the original equation. It's really important, go into the original equation. 3 times the square root of 12 plus 4 minus 2, and that's supposed to equal 10. And 12 plus 4 is 16. The square root of 16 is 4, so 3 times 4 is 12 minus 2 equals 10. Yay, it checks. Okay, so let's try number 6. This is kind of one of your homework problems, but we're going to do it together. So we have the square root of x plus 4 times the square root of x minus 8 equals 37. I need to isolate this x, but look, it's in 2 things. But we've already learned that we can add those together. This is just the same as 1 times the square root of x. So we have 5 times the square root of x minus 8 equals 37. So if I add 8 to both sides, 5 times the square root of 37, I don't like that 7 at all, equals 45. Divide both sides by 5. The square root of 37. Where did I get the square root of 37? Wow. Let's go backwards. Let me erase these. Try that again. 5 times the square root of x equals 45. Divide by 5, both sides, square root of x equals 9. That's better. So what do we do to get rid of the square root? We square both sides. So therefore x equals 81. But these are the ones that we have to check. So let's check it into the original. So the square root of 81 plus 4 times the square root of 81 minus 8 equals 37. Well, that's 9, and that's 4 times 9. So that means 9 plus 36 minus 8 equals 37, and that's a check. So that wasn't too bad, right? Okay, let's do this one. Okay, So we don't necessarily have x in the exponent, but we do have an exponent in our equation. So here we have the 1/4 plus 5 equals 3. Somehow we have to isolate that x to the 1/4. That's not too hard. I'm just going to subtract 5 from both sides. So x to the 1/4 equals -2. So x to the 1/4, if we raise that to the 4th power, think about it this way. 1/4 times what equals 1? Because we want that just to be x to the 1. Well, 1/4 times 4 equals 1 because they'll cancel. So we're just going to raise that to the 4th power. Maybe you think about it this way. X to the 1/4, we learned in the very beginning, we changed that, a fraction into a radical, and we said this is a 4 up here, and this is x to the 1 there. So how will we get rid of this? We would just raise that to the 4th power. Okay? Whatever you want to think about it. This is x to the 1/4. We'll take it to the 4th power. That gets rid of that. So we have x equals, it doesn't matter that this is negative. -2 times -2 times -2 times -2. Remember, it's an even. So therefore, we will end up with a positive. So we need to check it. So 16 to the 1/4 plus 5. 16 to the 1/4 is 2. 2 plus 5 equals 3? No. 2 plus 5 equals 7. So 7 does not equal 3. So therefore, there is no solution to this. Maybe because this is a negative, that would have been your clue, right? We can't have even roots getting to be negative numbers. Okay, so you might have noticed in the very beginning and thought, I don't think I have to finish that. However, it's always good to do that just in case. Alrighty, let's do number 8 together. So the y is raised to the 1/2 power, so we have to isolate this. So the first thing we're going to do, we're going to subtract 3 from both sides. Y plus 6 to the 1/2 now equals 11. So if I square that, that'll get rid of my 2's. So it means I have to square that side as well. So y plus 6 equals 121. Subtract 6. Y equals 115. I do have to check. Substitute 115 in for the y, plus 6 to the 1/2, which really just means the square root, plus 3 equals 14. So 115 plus 6 is 121. That's to the 1/2. Plus 3 equals 14. So what does the square root of 121 equal? We did that in the very beginning. That's 11. 11 plus 3 equals 14, and that one checks. Okay? Alrighty. One more. Exponential equation. A variable occurs in the exponent. So to solve 2 to the x equals 32, you're going to express 32 as a power of 2. So think about it this way. If I gave you 3 squared equals 3 to the x equals what? Well, that's not too hard. X equals 2. So what that means is if the base is the same, then the exponents must be equal. So our goal in this one, after we've isolated it, is to make sure that the bases are the same. All right. So here we have 4 to the x equals 32. This is a base of 4. This is a whole number, 32. we need to get them to a base of the same. So hopefully you recognize by now that 4 equals 2 squared and 32 equals 2 to the 5th. So look, base the same. So what they did was they said 2 to the 2, and then put the x on the outside. Does that make sense? We're substituting, instead of 4, we're putting 2 squared in here. The x is still on the outside, and our 2 to the 5th goes right there. So by doing that, we have 2x. Remember, parentheses means to multiply. So we have 2 to the 2x equals 5. So if the bases are the same, that means these have to be equal. So 2x equals 5, x equals 5/2. Let's try that again over here. Look at that, negative, because it's in the denominator. So we have 25 to the x equals 125. I think you can recognize that 25 is 5 squared. (25) equals 5 squared. 125 equals 5 to the 3rd power, right? So that's what they do. They put 5 squared in and 1 over 5 to the 3rd power. So 5 to the 2x makes sense. But you remember we've done this before as well. If it's in the denominator, then in order to move it up to the numerator, you have to make it negative. We change the sign. So 5 to the 2x equals 5 to the negative 3. So 2x equals negative 3, x equals negative 3/2. Let's try one. Number 12. We have 4 to the 3x and 64. 4 to the 3x and 64. All right, well, 64 is 2 times 32. Wow, this is 2 to the 5th, right? So therefore, 64 is 2 to the 6th power. 4 is 2 squared. So 2 squared, and we need to raise that to the 3x power, right? So therefore, this is 2 squared to the 3x equals 2 to the 6th. This is 2 to the 2 times 3. This is 6 over x. 6 over 8. I didn't even know what I'm writing here. Because this is 3x. So 2 to the 6x equals 2 to the 6th. So therefore 6x equals 6. Well, isn't that lovely? 6x equals 6. X now equals 1. Let's check that and see if it works. So let's do our check. 4 to the 3 times 1 equals 64. So that means it's 4 to the 3rd power equals 64. So what is 4 times 4 times 4? Lo and behold, that's 64. So it's a check. Okay? So I've done a couple of problems with you. I've done some examples. If you need to rewatch any of the video, it's here for you to do that. And your homework for tonight is to do 1 to 15, just the odds. 1 to 15 odd. I want you to try them, check the answers. If you don't understand them because you can't get it to work, I just need you to show me the work. And we will go over some more of these equations tomorrow as they get more difficult. But this is hopefully just a start for you. So 1 to 15 odd. Okay? Hope you have a great day. If you have any questions, you can send me an email or ask one of your classmates.